Hi everyone, welcome back to the video series on diffusion in solids or diffusion in multi-component solids. Okay, this is Sachin Kumar pursuing PhD. I'm in second year right now and my supervisor is Dr. Kaustubh Kulkarni. I'm working under the supervision of Dr. Kaustubh Kulkarni and my research topic is a diffusion in studying the diffusion in nickel based ternary alloy. So today's topic is discussion topic is about frame of reference. In last video we have seen the what is the definition of diffusion flux and what is its physical significance and how it can be implemented for the real time applications. Now we are talking about frame of reference. So before getting into the Fick's law, we need to know the some basic concept about frame of reference. So there are totally three frame of reference: the volume fixed frame of reference, mass fixed frame of reference, and mole fixed frame of reference. We will know one by one with the derivation. So volume fixed frame of reference, right? So fixed on the local center of volume of all the components, the net flux expressed in terms of the volume is 0. That is, I will write once, fixed on local center of volume of all components, the net flux expressed in terms of volume is 0. So it can be expressed mathematically like summation of Vi bar into Ji flux is equals to 0. This is molar volume. Okay. Then this Ji volume fixed frame of reference can be written in the form of moles of I to meter square per second. This is the unit. Okay, let's start with the deriving the equations. Okay, so first of all we are considering Ji into V is equals to, from the previous slide we obtained this equation. Here the flux at a molar fixed frame of reference is equals to flux with a laboratory fixed frame of reference minus concentration into velocity of this one. So when we are multiplying some molar volume on the both the side, then we will get it as minus summation of Ci UV UVI bar. So we know from the definition this term is 0. Then we can write it as 0 is equals to summation of Ji tilde Vi minus UV, and this summation of Ci into Vi is equals to 1. How it is possible? From the unit we know that mole per meter cube, and this molar volume is given as meter cube per mole. Mole get cancel, meter will cancel, then it results in the 1. That's why it's equals to. So then the velocity of an atom at fixed molar volume, molar fixed frame of reference, is given by summation of Vi into Ji tilde. This is the equation that we get from the molar fixed frame of reference. This is all about molar fixed frame of reference. Then when we are move towards next is mass fixed frame of reference. Fixed frame of reference. Okay, so this mass fixed frame of reference, it is similar to that of the definition is similar to that of the volume fixed frame of reference. That is fixed on local center of masses of all the components. Then the net flux expressed in terms of the mass is 0. Fixed on local center of masses of all the component net flux expressed in terms of mass is 0, right? So from the definition we can write it as flux at mass fixed frame of reference into molar mass is equals to 0. This is the definition. Same expression equal to Ji tilde minus Ci into UV. So to need to get this expression, we need to multiply and divide by molar mass on both the side. Okay, this is 0 from the definition. 0 is equals to summation of Ji tilde Mi. This can be written as density. Similarly, same case. This is mole per meter square per second. Sorry, meter cube into This is kg per mole. This mole get cancelled. Kg per meter cube is density. Correct? Yes. Then the velocity of an atom at fixed molar fixed frame of reference is given by summation of gi into mi divided by a rho. It's a simple one, right? This is the velocity of an atom at a fixed mass of the fixed frame of reference. Mass fixed frame of reference. Okay, these expressions are very important and they can be asked in the interviews. Then the third one is mole fixed frame of reference. So if you know one fixed frame of reference, and other two are very easy to understand. So mole fixed frame of reference. So I will write definition directly. Fixed on local center of number of moles of all component, then the net flux expressed in terms of number of moles is 0. Then from this definition we are knowing that Gi number of moles is equals to 0. So from the definition, basic equation equal to Ji tilde minus Ci into Un. Then from the definition, this is directly 0, adding summation Ji tilde summation of Ci into Un. Then Un, velocity of an atom at a mole fixed frame of reference, is given by summation of Ji tilde to the summation of Ui. This can be written as molar volume and Ji tilde, right? So sorry, in the previous session I have used this as molar volume. This is partial molar volume. So this is a partial molar volume and this is molar volume. Please note down the differences. Sorry for the inconvenience. This is all about the fixed frame of reference that have been used in this division in solid, right? So next we are getting into the most famous law, that is Fick's law. I require some of the time to explain this derivation as well as the concept behind the Fick's law. The Fick's law says that diffusion flux of an eye is proportional to the concentration gradient. This, I think, almost all the student will know these things. J, that is a flux of I, is directly proportional to concentration gradient. To remove this concentration gradient, we are writing a coefficient called as diffusivity coefficient or interdiffusion coefficient, D. So I have written, just observe the equation here. In advance, there are two hidden concept is there. First of all, I have written this negative sign. So what is this indication? I will tell in the further concepts. And I have written the not a complete differentiation, it's a partial differentiation I have written. This is actually, we can write it as partial complete perfect derivation. Here the time is also a dependent quantity, that's why I written this one. So this is usually the case. You can write it as this expression. So I will explain this negative sign why we are using in the upcoming video. This is about definition of the Fick's law. An analogy of the Fick's law is given to Fourier law and Ohm's law. They are similar kind of an expression it is having. I will write three expressions: Fick's, Fourier, and third one is Ohm's. So Fick's expression, we know this, flux is equals to minus d into dc by dx, whereas for the Fourier, heat flux is equals to minus ka into dt by dx, whereas for the Ohm's law, that is flux of electric current is equals to electrical conductivity into electric potential gradient, dV by dx. See, we have these, all the three is having same kind of an expression. So that's why they are analogous to each other. So first of all, the Fick's explained his law with a salt solution and the pure water. This is saturated salt reservoir, and this is pure water reservoir. So here the salt will, this is consisting of pure water and this is consisting of saturated salt water. So salt will diffuses from higher concentration gradient to the lower concentration gradient. And when we are dividing a small part of this column, it's the salt concentration remains same at any time. Hence, he is attained the steady state. Is achieved by Fick's. So steady state means at any position the concentration will not change with the time. This is x1, x2, x3, 1, 2, 3, 4 position. At any position, the concentration will remain same at any time. At this fixed position, if it is concentration is considered as C1 and it will remain C1 at any time, then we can say that this is steady state is achieved. And the salt will diffuses from bottom to top. This reservoir will maintain the concentration of the both the things, like in water and here salt is constant throughout the experiment. This is the experiment conducted by the Fick's, and he proposed this equation J is equals to minus D into dou C by dou X. So this negative sign indicates that diffusion will occur down the concentration gradient. Down the concentration of a gradient. This is all about the introduction to the Fick's law, and we can also derive this expression by considering the discrete atomic jump model. In the upcoming video. So complete derivation will be explained, what is the nomenclature that we have been used and what is the flux. Everything is explained in this derivation in the upcoming video. Thank you.